Hello everyone, welcome to my YouTube channel MK Maths. In last videos we have discussed about these three relations: reflexive relation, symmetric relation and transitive relation. So we have completed the definition with examples. So if you not watched those videos, so you can check my description. In description I have mentioned all of the videos so that you can click that link and you can watch all my previous videos so that you will get a overview and uh, some explanation about the definition and examples. So after listening that definition and examples, then we can easily solve the 3 marks question problem, because from these three types 3 marks question will arise in a PU board. So that if you want to solve these 3 marks question, then definitely we should know about reflexive relation, symmetric relation and transitive relation. And one more relation is created. One more relation we can create by using these three types of relation. So here, if R satisfies these three relations means these three relations are nothing but reflexive relation, symmetric relation and a transitive relation. Then R is nothing but a equivalence relation. Equivalence relation. Now this is the new type of relation. If we want to show or prove the R is equivalence relation, then we have to prove R is reflexive relation, then we have to prove R is a symmetric relation, then we have to prove R is a transitive relation. If R satisfies the definition of these three types of relation, then we can say that R is nothing but a equivalence relation. To satisfy the definition of equivalence relation, first R should satisfy these types of relation. Okay, I hope you understood this equivalence relation. Equivalence relation nothing but, if they ask to find equivalence relation, we find reflexive, symmetric, transitive itself. If any one of them is not satisfying the if any one of these three, reflexive, symmetric, transitive, is not satisfying which is given in R, then we can say that R is not equivalence relation. Okay, so let's move to 3 marks question. So from this chapter, I mean from this concept relation, we can get a 3 marks fixed question from PU board. Okay, so they ask two types of questions here. One type is nothing but show that or prove that R is equivalence relation. One type of a question is nothing but show that or prove that R is equivalence relation. Next, another type of question is they will ask for us to verify the given R is reflexive, symmetric, transitive or not. So they ask a question, check or find R is reflexive or not, R is symmetric or not, R is a transitive or not, R is equivalence relation or not. They ask us to find, they ask us to check, they ask us to verify. So first type of question is they just ask show that or prove that R is a equivalence relation. It means we have to just show the given R is reflexive, symmetric and transitive. The given R is satisfying the definition. We have to show that much. So in the second type of question, we have to verify the definition and we have to conclude that R is a reflexive or not, and we have to verify for these symmetric, transitive, and we have to conclude the given R satisfies symmetric or not. So given R satisfies the equivalence relation or not equivalence relation, we have to verify each and everything. So when it comes to first question, there is nothing to verify much, just we have to observe the given R is satisfying the definition. We have to mention the given R is satisfying the definition, so that we can say that the R is reflexive, symmetric, transitive, like that. Just we have to say here we have to prove, we have to verify. Okay, I hope you understood these two type of question. Let us understand one by one by solving a problem, so that we can get a clear understanding about these type of relation, and also how to apply these definitions in problems also we will understand. Okay, so let's move to the our fixed 3 marks question, which are important question. If we practiced one or two questions from one or two questions, then definitely we can solve each and every problem, because all problems are look similar. So we have to understand and we have to practice those important one or two questions, so that we can answer any problem in this relation chapter. Okay, so let's start with the first question. Here the first question says, let T be the set of all triangles. So T is the set here. So here T is nothing but a set. So in previous videos or in previous definition, while explaining definition reflexive symmetric transitive, I have taken the set A. So in this question they have taken this T is set. Now T has mentioned in set of all triangles. So in T contains all type of triangles: equilateral triangle, isosceles triangle, right angle triangle, obtuse, acute, all type of triangles and all in all type of angles are present in this set T. Okay, so in a plane, set of all triangles in a plane means it is nothing but a two dimension thing they are mentioning. With R is nothing but here relation. So they are saying R is relation, R a relation in T. Here T is the set of all triangle and they are creating a relation R by using this T. That R is defined by, given by R equals to T1 comma T2, ordered pair T1 comma T2, such that this symbol is nothing but such that T1 is congruent to T2. T1 is congruent to T2. I hope you all know about congruent concept, because this congruent is nothing but triangles having same shape, same size. Congruent means triangles having same shape, same size. Similar triangles means congruent having same shape, different size. Okay, so here they have mentioned this T1 is congruent to T2, means we have to consider two triangles from set triangle T, and we have to they created a relation between, they have created a relation between two triangles. That is not, that relation is nothing but congruent. This is a congruent symbol. So T1 is congruent to T2 means both triangles looks in same shape and same size. Now we have to prove this relation is, this relation is equivalence relation. See here, we have to show here, show that R is equivalence relation. This is the first type of question I have mentioned. Show that, prove that, they give a question like that. So this comes under first type. So show that R is a equivalence relation. So now our target is to show R is a reflexive relation, R is a symmetric relation, R is a transitive relation. If R satisfies these three relations, then clearly we can say R is equivalence relation. Here they have mentioned show that R is equivalence relation, means we have to understand R is already a equivalence relation. Just we have to show R is a equivalence relation. There is nothing much work here. Just we have to focus on definition and we have to say, so it is same as a definition. So we are concluding it as a reflexive, we are concluding it as a symmetric, we are concluding it as a transitive. There is nothing much to verify or check. It is reflexive or not reflexive, it is symmetric or not symmetric. There is nothing much work here, because they have already mentioned show that R is equivalence relation. It means they indirectly saying R is already a equivalence relation. Just we have to show. It means we have to show R is a reflexive, we have to show R is a symmetric, we have to show R is a transitive. Let us understand how to show here, how to show the given R is a reflexive, how to show the given R is a symmetric, given R is a transitive. So we have to learn and we have to understand the procedure, how to write this method to show the reflexive, symmetric, transitive, so that we can get a 3 marks here. Okay, so let's start with the reflexive relation. So here I am writing it as reflexive. This is solution, reflexive. So I am just showing now reflexive. See here, our main target is, so for to show reflexive, definition says A comma A belongs to R. A comma A belongs to R. In definition I have mentioned, for all A belongs to set A, implies A comma A belongs to R. So this is the definition. So actually ordered pair is, we write ordered pair as A comma B. Ordered pair ordered pair we mention as A comma B, which means A is related to B. To prove or to show reflexive relation means A is related to A, the element A should relate to itself, then only we say it as a reflexive. So then our target is to change the B as A. The second element B is there, so we have to change the second element in order pair as first element itself, because both should be same A. If both should be same means we have to change this B as A. That's it. If we change the second element B as A, then it is satisfies the definition of a reflexive relation, then it is a reflexive. That's it. So here our target A comma B, I have mentioned ordered pair A comma B, but in our question, see here, in our question we have ordered pair. Just observe the question. In R we have a ordered pair T1 comma T2. If ordered pair L1 comma L2, there will be ordered pair P1 comma P2, ordered pair A comma B, ordered pair X comma Y. Like that there will be a order pair they mentioned in R. So we have to catch that order pair. So here, see, in our question we have a T1 comma T2. T1 comma T2 is nothing but triangles. To represent the triangles they have mentioned T1 T2. Okay, so our target is here, we have to replace this T2 by T1. We have to replace this T2 by T1. Our first target is we have to replace this second element T2 as T1. Then if we replace T2 as T1, now automatically this order pair looks like T1 comma T1 comma T1 itself. So our main target is we have to replace second element T2 as T1. So this is our target. So I am writing it in bracket. So it means to show or to prove reflexive means our main target is to change the second element T2 as T1. So now it becomes given. So the given relation is, I am writing here, given relation is T1 is congruent to T2. So this is the given. T1 is congruent to T2. Next it becomes T1 is congruent to, in the place of T2, now I am writing it as T1. In the place of T2, I am writing it as T1. So I have changed this T2 as T1 now. So T1 is congruent to T2. Obviously, that same triangle is same size, same shape, same size to itself. If you take one triangle and if you compare the size and shape of that triangle itself, it will be obviously same. So we can say here which is true. If which is true means we can easily write here T1 comma, in the place of T2 we have changed T1, the relation is not changed. So here I am writing T1 comma T1 belongs to R. Therefore R is reflexive relation. Therefore R is reflexive relation. I hope you understood the reflexive concept here. Okay, in same way, so now we have to prove symmetric. So now we have to prove symmetric. So symmetric, what is the target of symmetric? Symmetric target is easy. So if we have definition says A comma B belongs to R and also B comma A belongs to R and also B comma A belongs to R. It means if ordered pair A comma B is in R, we have to interchange now. B has to come in the place of A and A has to come in the place of B. Now the B has to come in the place of A, so it becomes B. A has to come in the place of B, it becomes A. So now both interchanged, B comma A. So B has came to the place of A and A has came to the place of B. Now these ordered pair B comma A belongs to R. So it means to prove a symmetric or to show a symmetric, we have to interchange the first and second elements in the order pair. So after interchanging the first and second elements in the order pair, if relation is not changed, the meaning of relation is not changed, then we can say R is a symmetric relation. That is our main target here. So in our question there is T1 and T2. So our target is to interchange the T1 and T2. In our question, if we having a comma B means we have to interchange A comma B. In our question we have X comma Y means we have to interchange X comma Y. Depend upon question we have to change. So in our question T1 T2 is there. So I am writing here our target is T1 changes to T2 means wherever T1 you see, you write it as a T2, and wherever T2 you see, write it as a T1. So this is our target. Symmetric means we have to interchange T1 and T2. So first let us consider, first we have to consider the order pair. To reverse, first we should have a order pair. So T1 comma T2 belongs to R. T1 comma T2 belongs to R. If T1 comma T2 belongs to R means question itself says T1 is congruent to T2. T1 is congruent to T2. So this is question itself. So I have written question T1 is congruent to T2. Now our target is to interchange. Let's interchange T in the place of T1 I have written T2. In the place of T2 I have written T1. So now the sentence becomes T2 is congruent to T1. So I have interchanged in the place of T1 I have written T2. In the place of T2 I have written T1. So here I am interchanging the places, first and second place. So now the relation is also true, because if this triangle is congruent to this triangle means obviously this triangle is congruent to this triangle. So which is true. So if which is true means we can conclude T2 comma T1 belongs to R. Therefore R is symmetric relation. R is symmetric relation. So this is the symmetric. So for reflexive, our target is to change T2 as T1. That's it. In symmetric means our target is to change T1 to T2, T2 to T1. Same. We should not change sentence which I have given in question. We should not change any sentence. We should just focus on AB. We should just focus on X comma Y. We just focus on T1 T2. We just focus on L1 L2. So whatever the question ordered pair they have mentioned elements, we have to play with those elements only. We should not touch any sentence. We should not touch any relation in R. Okay, see here they have given T1 is congruent to T. See the sentence. I have writing the sentence as it is. So here T1 is congruent to sentence I have written as it is. Just I am playing with the elements. Just I am playing with here T1 T2. If question has a comma B means we have to play with A comma B. That's it. So reflexive means we have to change the second element as a first element, then both elements will become same. Symmetric means we have to interchange. In the place of T1 we have to change T2. In the place of T2 we have to change T1, because by interchanging only those relation will shift from T1 is congruent to T2. We have to check T2 is also congruent to T1 or not. So that's why we have to interchange the elements here. So in second part also T2 is congruent to T1. Obviously it is true. So T1 comma T2 comma T1 belongs to R. R is a symmetric relation. Symmetric relation will be, we have concluded this. R is a symmetric relation. I hope you understand reflexive and symmetric. Let's move to transitive. So this is, now let's move to transitive. So here okay, let's move to transitive now. transitive. So here transitive, so let's see what is the our target to prove a transitive. So in transitive, in last video I have explained about transitive definition, and in last video I have explained about the definition of transitive and examples. If you not watch that, please go and watch the definition and example, so that it will be easy to understand the problems. Okay, so now focus on the transitive. So transitive definition is nothing but, first let us take the basic definition. A comma b ordered pair A comma b should be in R, and ordered pair B comma C should be in R. Both should be in R. So A comma B belongs to R and B comma C belongs to R. We have to check, we have to show this first and last A comma C, which is also belongs to R. If first and the last element ordered pair A comma C belongs to R, then obviously we can say it as a transitive. So here our target is, we have a, we have a B, we have a C here. So we have to show this first and last element is related. So first and last element is related in given R. So if we want to show this first and last element is related, means this middle part B, this second element B, we have to neglect. We have to eliminate. So this is our target. So if we have T1 in our question, we have T1 is related to T2. Next I take we have to start with the second element. T2 is related to T3, and we have to show this T1 is related to T3, means we have to eliminate this second part, see, this second element or this middle element, we have to eliminate that T2. So our target is, if we consider x, y, z, means we have to eliminate this y, then only we can relate a first and third element. So after removing or after eliminating a second element, we can easily relate first and last element. So that is the target here. So in transitive, so in transitive we have to eliminate T2 eliminate. So this is target, eliminate, or we can neglect T2. So first let's consider, we have to consider a pair now. First T1 comma T2 belongs to R, and T2, we have to start with the T2 comma T3 comma T3 belongs to R. We have to first consider T1 comma T2 belongs to R, and T2 comma T3 belongs to R. T1 comma T2 belongs to R means, with the help of relation we can write T1 is congruent to T2. T1 is congruent to T2, and T2 comma T3 means T2 is congruent to T3. T2 is congruent to T3. Just change the relation with by using this order pairs. So we have considered order pair T1 comma T2 belongs to R. I have written sentence T1 is congruent to T2. T2 comma T3 belongs to R means I have written T2 is congruent to T3. Now our main target is eliminate this T2. Just neglect this T2. Just neglect. We have no T2 here. Just imagine we have no T2 here. Then what will be the sentence now? T1, therefore T1 is congruent to last T3. T1 is congruent to T3. T1 is congruent to T3 means which is true. How we can write which is true? So if a first triangle is congruent to second triangle is congruent to third triangle, means obviously first and third triangle will be same shape, same size. So which is true. T1 comma T3 belongs to R. So first element and last element, ordered pair of first element and last element belongs to R. R is transitive relation. Hence So R satisfies the reflexive relation definition, R satisfies the symmetric relation definition, R satisfies the definition of transitive relation. Then last we can conclude that hence R is equivalence relation. Equivalence relation. R is equivalence relation. We can conclude here R is equivalence relation. I hope you all understood this concept. So in same way they ask question here in the place of congruent, in the place of congruent here, in the place of congruent, in the place of congruent, they mention the word similar, similar triangle. See, they mention the word similar. T1 is similar to T2. Same, they have give question T be the set of all triangle in a plane with the R relation in a T given by R ordered pair T1 comma T2. T1 is T1 is congruent to T2 is there, no? So in the place of congruent, T1 is similar to T2. Then show that R is a equivalence relation they ask. So you can use this concept same for that problem also. So for reflexive you have our target is second element T2 change as a T1. So given then the given will be T1 is here in the place of congruent, right? Similar. T1 is similar to T2. Next T1 is T1 is similar to, in the place of T2 we have to change T1, which is true. Ordered by T1 comma T1 belongs to R. R is a reflexive. Finished. Next for symmetric our target is just interchange the T1 as T2 and interchange the T2 as T1. So let T1 comma T2 belongs to R. T1 is, we have to change the sentence here. T1 is similar to T2. T2 is similar to T1, which is true. So T2 comma T1 belongs to R. R is a symmetric relation. Same now. So when it comes to transitive, we have to eliminate this second element. We have to eliminate the second element T2. So same T1 comma T2 belongs to R and T2 comma T3 belongs to R. Here we have to change the sentence now. T1 is similar to T2 and T2 is similar to T3. Therefore T1 is similar to T3, which is true. Ordered by T1 comma T3 belongs to R. R is a transitive relation, hence R is a equivalence relation. So this will be the same again. So next they change this congruent as parallel. They change parallel. So in the place of T1 T2 they may give L1 L2 because parallel means this is nothing but for lines. So they can give a lines L1 and L2. L set capital L be the set of all lines in a plane with R relation in L given by R equals to L1 comma L2. Just that L1 is parallel to L2, so that R is a equivalence relation. They mention same sentence, they have changed some alphabets, they have changed, that's it. Procedure will be same. So in reflexive we have to change that L2 as L1. Same, L1 is parallel to L2, L1 is parallel to L1. We have to write same sentences, just to focus on here this part. Here T2 as changed to T1. So this is important. In symmetric, T1 has changed to T2 and T2 has changed to T1. This is important here. In transitive, we have eliminated this T2. We have eliminated this T2 and connected this first and last elements and concluded transitive relation. I hope you all understand this problem. So in next video let us solve some more problems, 3 marks important problems, so that we can get a clear understanding about this reflexive, symmetric, transitive and as well as a equivalence relation. I hope you all understand this problem. Please if you not subscribe my video, so please do subscribe and like the video and also share to others so that it reaches larger audience, so that it gives a motivation to me to do a more and more videos and upload a more and more content about the maths. I hope you all enjoy my videos. See you in next video. Thank you. Bye bye.